What's up, everyone? I'm still Dr. Morris, and today we're going to be talking about alkanes and cycloalkanes. These are just two carbon and hydrogen containing molecules, and in this lesson, we're going to first introduce what alkanes are, then we'll talk about what cycloalkanes are, and lastly, we'll work some practice problems where we go back and forth between the names and the structures of these different molecules. First up, what are alkanes? Well, alkanes are organic compounds containing mostly carbon and hydrogen. And there's more to the definition, which we'll add in just a second. But we're starting here. They contain carbon and hydrogen. So here we have a common alkane called a butane. Butane has 4 carbons. So anytime you have this string of 4 carbons, you got butane. And it also has hydrogens. Remember that in our line angle structures, we don't explicitly show the hydrogens. We just expect other people to know that carbon needs 4 bonds. And if it doesn't have 4 bonds, we're going to fill it all the way up to 4 by adding hydrogens. Now, the reason I have an oil rig drawn here is that it turns out petroleum and gasoline are made largely of alkanes. It's really a complicated mixture of molecules, but alkanes are harvested and they're often used as fossil fuels. So, right, octane, heptane, methane, butane, these are all alkanes that we can burn. All right. Second thing you should know about alkanes is that their carbon-carbon bonds are always going to be single. Okay, so that means you're only going to have single bonds. If you have double bonds, that turns out to give you what's called an alkene. So very similar name there. And if you have triple bonds, then we have what's called an alkyne. And we'll study those in later lessons. But if you have a single bond, which is what we have throughout this entire molecule, then we have an alkane. So single bonds, that's called an alkane. And that's what we're looking at now. Okay? Last thing to know, alkanes always follow a certain formula for the number of carbons and hydrogens. Let me show you the formula, then you can freak out, and then I'll explain it. Okay, they always have the formula of CnH2n plus 2. What the crap does that mean? Okay, all it means is that if we take the number of carbons in an alkane, and we multiply it by 2 and add 2 to it, we'll get the number of hydrogens. For example, here we have 1, 2, 3, 4 carbons. So in this case, we'd write C4. That means our N is equal to 4. So if I want to know the hydrogens, all I got to do is take N and multiply it by 2. So I'm going to do 2 times 4 plus 2, which would give me 10. So C4H10 is going to be the correct formula there for butane. And you'll see that if we actually go the long way and count the hydrogens, this N1 has 3, and this one has 2. This one has 2, and this end one again has 3. That you get that same number of hydrogens. There's 10 hydrogens drawn there. And you can even see why we have the 2n plus 2. Because notice every single carbon gets 2 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. And then the end points get an extra one. That's where that plus 2 comes from. So we multiply it by 2 and we add 2 and we get the number of hydrogens. Okay, so that's what you should know about alkanes for right now. They form the base backbone of many, many organic compounds. So you're going to use this over and over again, and these alkanes are going to get slightly more complicated each time. All right, so this is just sort of the base level of thinking about these organic molecules. All right, so here's the name of the first 10 alkenes, and I've left off the molecular formula in some case. We're going to actually write it using our formula. So the very first one, methane, has just 1 carbon. So these just go in order. This has 1 carbon. This has 2 carbon. That has 3, 4, 5 carbons. And then hexane has 6, heptane has 7, octane has 8, and decane has 10. But not oxygens, carbons. What in the world? That ain't right. C8, C10. Okay. So now let's go ahead and fill in the rest of the formula. So if I have 1 carbon on methane, then I multiply 1 by 2, and then I add 2 to it. So that's going to give me 4. So methane is CH4, just 1 carbon. Ethane is C2, and now that means my N is 2. If I multiply that by 2 and add 2, 2 times 2 is 4, plus 2 is 6. Why don't you pause it and see if you can think about what the rest of those formulas would be. Pentane has 5, and so we're going to multiply that by 2 to get 10, and then we're going to add 2, so that'll be H12. And then octane, we're going to multiply by 2 to get 16, and then add 2 to get 18. Lastly, decane, we're going to multiply by 2 to get 20, and add 2 to get 22. Okay, so what you can see here is the first 10 alkanes. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. You got to memorize those because we use them over and over again. In fact, even if you don't try to memorize them, you'll pretty much end up memorizing them. After butane, they're pretty easy. Pentane, you can kind of remember that pent refers to 5, pentagon, for example. Hex, we can remember, refers to 6. Hep is 7, oct is 8, nona is 9, and dec, like decade, is 10. Those kind of make sense. The ones that typically are hard to remember are these ones: methane, ethane, propane, and butane. Because methane, ethane, propane, and butane don't sound like 1, 2, 3, and 4 carbons. But whenever I have a molecule with, say, 7 carbons, that's going to be heptane. So you'll have to commit this list to memory, which you'll pretty much do as you go along through the different naming videos. Okay, let's go ahead now and think about what are cycloalkanes. Well, they're very similar to alkanes. They're organic compounds containing carbon and hydrogen. The carbon-carbon bonds are single. But here's the new thing. The carbon bonds complete a ring. So this guy, that's pretty cool. It's a square. It also is a line angle formula. How many carbons are there? 1, 2, 3, 4. Now, if I want to name it, when I have 4 carbons, remember I have butane. But to tell you that I have a cyclobutane, I just put cyclo in front of it. That tells you, hey, I got a ring of it. So cyclobutane means this guy. If I just write butane, it means the straight one we've been looking at before. So for naming, all we do is we just add cyclo before the alkane name. Pretty straightforward. All right. Now, one other thing that changes when we go to cycloalkanes is the formula that they're always going to have. So remember that for our alkanes, we had CnH2n plus 2. What is it going to be for cycloalkanes? This is a hard one, but if you pause it and figure it out, then really well done. That's hard, but give it a try. Let's just figure out what the formula is for cyclobutane, and we'll go from there. This guy has 1, 2, 3, 4 carbons, so we know it's C4. How many hydrogens does it have? Well, this first carbon here has 2 carbon bonds going off of it, which means it needs 2 hydrogens. And actually, every single one is the same. All of these need 2 hydrogens to get to the 4. So there's going to be exactly 8 hydrogens. So what that means then is that the formula in this case is actually going to be CnH2n. And that kind of makes sense because we no longer have those terminal carbons that have 3 hydrogens each. Every single carbon just gets 2 hydrogens. And so the formula always follows the pattern, CnH2n. Okay? All right, let's do some practice. Practice problem 1. Write the molecular formula for pentane and cyclopentane. Okay, so we have to remember at this point that pentane means 5. So we have to remember pentane means 5 carbons. And that's why you have to memorize it. You'll just be expected to do this really often. Okay, so pentane means 5 carbons. And so then if we're just looking at pentane, then we know we have C5. And since it's an alkane, we follow this formula. We multiply the number of carbons by 2 to get 10, and then we add 2 to it to get 12. So it becomes C5H12. Meanwhile, cyclopentane follows our second formula, where we write C5 still, because it still has 5 carbons. That's what the pentane part means, right? But now we follow this slightly different formula, where we just multiply the number of carbons we have by 2, and we get C5H10. So those are the formulas for pentane and cyclopentane. Let's look at 2 more practice problems. Here, we're told to draw the line angle formula for propane and pentane. Again, the first thing to do is to take a look at a chart that tells you how many carbons each of these have, or to have memorized it, which hopefully we'll do eventually. Propane has 3 carbons, and as we just saw in the previous lesson, or the previous practice problem, pentane has 5 carbons. Okay, so for propane, we're going to draw a chain of 3 carbons. What does that look like? Well, all we're going to do is draw line angles like this until we get to 3 carbons. So let's think about how to do that. The very first line we draw, how many carbons have we represented? 1, 2. So if I stopped there, I would be representing the compound ethane. All right, but I'm going to keep going. I'm going to add 1 more line. Now how many have I drawn? 3. 1, 2, 3. So what does that represent? Now that is propane. Okay, so I've drawn propane there. And I'm done. That's easy enough. And now I want to draw pentane. So again, I just start drawing these line angles and I keep track of how many carbons I've drawn in each case. So that's 1, 2 carbons. So the first line segment you draw represents 2 carbons because it has 2 endpoints. When I add another one, I'm just adding 1 more endpoint. So that's adding 1 carbon. So I did, let's do that again. 1, 2, 3, 4, 5. Now I have 5 carbons. That's pentane. Okay, so you can see that drawing these line angle structures super convenient here. And for the alkanes, you just need to memorize how many carbons go with each name. All right, last practice problem. Name each of the molecules below. So this just involves counting the number of carbons and then adding cyclo if it makes a ring and not adding cyclo if it doesn't. So let's start here. How many carbons? 1, 2, 3, 4, 5, 6, 7. All right, 7, you may or may not remember, refers to heptane. So this would be heptane. And then we see, oh, you know what? This completes a ring, right? One nice continuous ring. So we're going to put cyclo in front of it. So that's cycloheptane. All right, why don't you pause it and try to name the next two? This next one is a triangle. Pretty sweet. And when a triangle is drawn, we know that each point is a carbon. So I got 3 carbons. Once again, we have propane. Maybe you remember that from the last problem. Maybe you're already starting to memorize it. So that's propane. And because it's a ring, what do we want to put in front? Cyclo. Do you ever sing songs about cyclopropane? No, just me? Okay, cool. Let's count the carbons in the last one. 1, 2, 3, 4, 5, 6, 7. Because there's 7 carbons, we call this guy heptane. So that's just regular old heptane. Notice that over here we put a cyclo because it was a ring, and over here we don't because it's just a straight line. So that is how we can name alkenes and cycloalkanes. Really important starting point for thinking about more complicated organic molecules.